Okay, good day, is FY here. So today we're going to look at the analysis of function. If you have fx is rational functions where you have the pattern of px over qx. So px is a polynomial, qx is also a polynomial. Okay, and this is a flowchart that we're going to use it in order to answer the type of example that is involved with rational function. Okay, so okay, let's just go to the first example first. Okay, so in here this is a rational function. Okay, so we have a rational function saying in this way. Okay, let's look at the first question first. Okay, we have to find the x-intercept and y-intercept. Okay, for the x-intercept, that is very direct. That is as whatever that we have did in the previous example. Okay, so you have to let your y equal to 0 in order to get your x. Okay, what is this y? Okay, the y is basically equal to the function f, that is your y. So let this one equal to 0. So basically you will have 0 equals to 2 plus x, 3 minus 2x. Okay, so and then you have 0 equal to 2 plus x, and x is basically equal to minus 2. So that is for x-intercept. For y-intercept, it will be like your x equal to 0. Okay, so now okay, you're going to find your y value. So your y is actually your function f that you substitute x as 0 inside. Okay, so you will have 2 plus 0 divided by 3 minus 2 multiplied by 0. So you will have y is equal to 2 over 3. So that is your y-intercept. So we have done for the part A, so we go for part B. So we are talking about vertical asymptote. Okay, if we are talking about vertical asymptote, that is the time we're going to refer to our flowchart. Okay, let's just look at the flowchart. Okay, we look at the flowchart. Okay, we're going to refer here. So it says that let your qx equal to 0 in order to get your x for vertical asymptote. What is your qx here? Your qx is actually your denominator. Okay, so let's just look at our example. So your example here. Okay, let me push it out a bit on this one. Okay, let me copy down the function first. Okay, so we have the function f. You're being given the function f that is 2 plus x over 3 minus 2x. Okay, so whatever that is on the top, that is your px. Okay, so whatever on the bottom will be your qx. Okay, so in order to find your vertical asymptote, so what you have to do is you have to let your qx equal to 0. Now what is your qx here? Your qx is actually 3 minus 2x equal to 0. So at the end we will have our x is actually 3 over 2, right? That is x is equal to 3 over 2. Okay, then the next is actually they asked us to find the horizontal asymptote. So horizontal asymptote. Well, let's just go back to the flowchart. Okay, so the flowchart says that okay, if you want to find the horizontal asymptote, so you have to let the y equal to the limit approaches the limit of x approaches to plus minus infinity, and you will have the rational functions. You have to solve it. Okay, so let's back to our question. You have to let the y equal to the limit x approaches to plus minus infinity, px over qx will be x over qx. Okay, so what is our px over qx here? So our px over qx, that is this one. Okay, so we will have 2 plus x over with 3 minus 2x. Alright, okay. So now, okay, you have to solve this just that you can get your horizontal asymptote. Okay, in order to solve this, you need to have some knowledge in solving the limit. Okay, but we have learned that in class, so I will repeat that. Okay, so what you have to do is you have to divide by the highest degree of the polynomial. So in here, obviously, is actually x, right? Okay, so in here, you have 2 divided by x and x divided by x, and you have 3 divided by x and 2x divided by x. If you can't remember, just refer back to the previous example that we have learned in the class in regards to limits. Okay, so okay, same thing. I'm going to simplify it. So if we simplify it, this one nothing that we can do. So it's actually 2 over x, and but this one, yes, we have 1. Is 3 over x. This is actually minus 2. Okay, and if you substitute the plus minus inside here, so we have 2 over plus minus infinity, that is basically give you a 0. Okay, same thing happened to here. You substitute the plus minus infinity here, you will have over 0. At the end, you will have your y is actually equal to negative 1 over 2. So that is your horizontal asymptote. Okay, now for the part B, so we have to go for part C, interval where the function is increasing or decreasing. Okay, so let's go back to the flowchart in order to answer this question. Okay, so if we are talking about the interval of increasing or decreasing, you can see that in this flowchart, I gave you 2. Okay, you have 2 options here. Which is the correct options that we need to use? Okay, so you have to trace back. So what you have to do is you have to begin to find the f prime first. Once you have find the f prime, then you have to check the critical point. Okay, and the option has come here, okay, where you either will go to this part if you are unable to get the critical point. If you're able to get the critical point, we'll go to here. Okay, so let's just go back to the question. Okay, so the first thing that we have to do is find the f prime. Okay, that is your function f. Okay, so still we back to our given function first. So our given function, that is 2 plus x divided by 3 minus 2x. Okay, so now, okay, in order to find your f prime, remember this is involved with the equation rule. So you have to let u and v. Okay, so you have equation rule here. So in order to find your f prime, so you're going to use the formula. What is the formula for the equation rule? That is v du minus u dv divided by v squared. Okay, let me push it up a bit on this. Right, okay, so what is our v here? Our v here is actually 3 minus 2x. Your du, that is this one. So that is du is actually equal to 1. Minus with your u is actually 2 plus x dv. dv that is here. So we differentiate, we will have minus 2. And then we will have v squared. So that is 3 minus 2x squared. Okay, let's just simplify it. So if you simplify it, okay, so this one will have 3 minus 2x. I bring this minus 2 in front. Okay, multiply with this minus, I will have positive 2. Okay, at the bottom I still have this one. Again, you can expand it. Okay, I just deal with this 2 only. Alright, okay. Let's just expand it. If you expand it, what happens? So we will have 3 minus 2x. This one is 4 plus 2x. Okay, minus 2x plus 2x, you can cancel. Okay, when you cancel out, so what do you get? You got 7 divided by 3 minus 2x square. So that is your f prime. This is your f prime. Okay. So what is the next step after you have find the f prime? It says that you need to check the critical point. The step to check the critical point, that is, you have to refer to the previous flowchart, that is, the function is polynomial. You have to refer to the previous flowchart. I have shown you in the previous video, just refer back if you can't remember. So the step, okay, I'm going to do here. So the step to find the critical point, if you still remember, the step to find a critical point, that is, you let your f prime equal to 0. Okay, so you're going to let this one equal to 0. So you have 0 equal to 7, 3 minus 2x squared. Okay, what happened is, if we solve this one, we will have 0 equal to 7. Okay, where as we know that it's impossible to have a 0 equal to 7. Okay, that is impossible to have 0 equal to 7. So it means what? It means that actually you have a case of, we call it as false statement, that is impossible to have any value, okay, any 0, to have a 0 equal to any value. Okay, that is impossible to have, is no way. Okay, so this is we call as false statement. So when you have false statement, it means that you do not have critical point. So you have no critical point. Well, what happens when you have no critical point? So means that after you have checked on this step, so you're going to look at this part. So you are actually unable to get critical point. You have false statement. So you're going to use this one. So you're going to build the table. And this table, they ask you to use the x from vertical asymptote. Okay, so you're going to use the x from vertical asymptote to build an interval table. Just now we did it right. We find it here. We found it here. Okay, which is your vertical asymptote. So we go back to our questions. Where is our vertical asymptote? So this is our vertical asymptote. Okay, so we're going to use this one, x equal to 3 over 2, to form the interval table. Okay, that is your x equal to 3 over 2 to form interval table. So we just have one number, that is 3 over 2. So 3 over 2 on here, we have 3 over 2. So means that we only have this number. So this number will form our interval, that is from negative infinity until 3 over 2. And then 3 over 2 until positive infinity. Okay, that 3 over 2 must be excluded from the interval, because if you put the 3 over 2 into here, okay, if you sub the x as 3 over 2 in here, you will have 2 multiplied with 3 over 2, and then you will end up with 3. So 3 minus 3 is 0. So we could not have something divided by 0. Okay, so that's why we excluded the 3 over 2 in the interval for both columns. Okay, again we're going to repeat the same step that we have done in the previous example. We will put the test value for each interval. So we will put test value. So in here I'll put 0, and in here I'll put 2. Okay, and then we will test the sign of your f prime. Okay, so we substitute in here to check the sign. So in here we obtain this is a positive value, and substitute in here you have a positive value. So that is your table. Okay, basically from this table we only have the interval of increase. So we only have the interval of increase. So that is from negative infinity to 3 over 2. Okay, union with 3 over 2 to infinity. Okay, so do not join these two interval because the 3 over 2 is actually excluded. If you join it, it means that it's included the 3 over 2. So just leave it this way. Okay, so we have done with the part C, interval where the function is increasing or decreasing. So the next question is we need to figure out the interval where the function is concave up and down. So again, let's just refer to the flowchart. Okay. Okay, if you look at this flowchart, okay, you have two options for the interval of concave up and down. Same thing. So you have trace back. Okay, you have trace back where this step begins. Okay, so it's actually traced back to inflection point. Okay, before inflection point, you have F double prime. Okay, so first step, find the F double prime first. Okay, so back to our questions. You have this. Okay, we need to have the F double prime. Okay, since you have your F prime is equal to 7 over this denominator, you can use equation rule, but we have a more quicker way. We have a quicker way to solve, that is just change it to 3 minus 2x minus 2. Okay, so for this function you can use the chain rule directly instead of using equation. Equation you will also have the same answer, but you have a longer way to solve. But chain rule will give you a quicker answer. So F double prime, that is you can multiply this in front, so we have 14 and 3 minus 2x. Okay, and minus 1 here, so we have minus 3. Okay, and then differentiate this. If you differentiate this, we have minus 2. Okay, and simplify it. Okay, when you simplify it, we have minus 28 divided by 3 minus 2x power of 3. So that is your F double prime. Okay, once we have obtained our F double prime, back to the flowchart one more time. Let's say what? It says that please check the inflection point. Okay, we do not use this type because we do not have critical point, right? Okay? Remember just now we said we have no critical point. We don't have to further to the relative extremum, just directly to the inflection point. So just recall back the things that you have learned in the previous subtopic when your function is polynomial. Okay, I push it out a bit, right? Okay, let's just go to the inflection point first. Okay, if you need to find the inflection point, so the thing that you have to do is you have to let your F double prime equal to 0. That is this one. You have to let it equal to 0, so we have 0 equal to minus 28 over 3 minus 2x power 3. As a result, you will have a 0 equal to minus 28. Again, this is another false statement where 0 could not be equal to negative 28. This is another false statement. So what happened when we have false statement? So if you look at here, so from this place, okay, after you have found the inflection point. Okay, actually the inflection point is impossible to have because we have false statement. So actually you are going to this step. So we're not going to here, but we go to here. So you are unable to get inflection point because you have false statement. So it says what? It says that use the x from vertical asymptote again. Use the x from vertical asymptote. So, and then you build the interval table to find the interval of concave up and down. Okay, so you need to use the x Okay, so since you have no inflection point, so means that you have to use your vertical asymptote. Okay, what's your vertical asymptote? Okay, that is x equal to 3/2 to build the table. Let's build the table. So we have interval. Okay, we just have the same number that is 3/2 here, 3/2 here. So means that you have negative infinity until 3/2, excluded the 3/2, 3/2 to infinity, and we're going to put the same test value. So that is 0 and 2. You can put anything as long as that number is in that particular range. And okay, now we're going to check the sign of f double prime. Okay, so in order to check the sign of f double prime means that you have to substitute the x equal to 0 into here, and it basically give you a positive. Okay, and sub the x equal to 2 into here, so you will have the negative sign. Right? So then, okay, we could write out the conclusion for the interval that is concave up. Okay, interval concave up. Okay, we just do the same thing. The interval concave up must be a positive value, and negative value that is for concave down. Okay, so concave up that is negative infinity until 3/2, and interval of concave down will be another interval that is 3/2 until positive infinity. Concave down. This down. Alright, okay. Then the final question that is to sketch the graph. Okay. So in order to sketch the graph, there are few information that we require to have. So we need to have the informations of the x-intercept and y-intercept. Okay, we need the information of x-intercept, y-intercept. That is x equal to -2, y equal to 2/3. We need the information of vertical asymptote. That is x equal to 3/2, and horizontal asymptote, that is y equal to -1/2. Okay, let me jot down here, okay? Let me jot down at the bottom. So we have the x-intercept, that is x equal to -2, y-intercept, that is 1 equals to 2/3. And what else that we need? We need the vertical asymptote. Vertical asymptote, we have x equal to 3/2, and the horizontal asymptote, that is y equal to -1/2. Okay, and we also need the informations of the two tables that we did just now. That is the table of interval of increasing or decreasing. That is this table. And also we need this table of concave up and down. This is the table. This is the table of interval of increase or decrease. And this is a table of interval of concave up or down. Okay, the first thing that we have to look at that is the asymptote. Okay, so we have vertical asymptote and the horizontal asymptote. Okay, so let's just draw the x and y axis first. So we have y, and then we have the x-axis. So x equal to 3 over 2. So x equal to 3 over 2, that is roughly here. Okay, so we have a dotted line. The dotted line means that you have an asymptote. Asymptote is a line that your curve cannot pass through. So that is your vertical asymptote. Is your vertical asymptote. Okay, so then we have the horizontal asymptote. The horizontal asymptote, we have y equal to minus 1 over 2. And this is roughly anyway. Okay, so we have minus 1 over 2. Okay, so then we have the dotted line again. So that is y equal to minus 1 over 2. That is your horizontal asymptote. Alright, okay, then we're going to look at the x-intercept and y-intercept. So for the x-intercept, we have x equal to minus 2, roughly here. So we have minus 2. So later we're going to intersect here. And we have the y-intercept, that is 2 over 3, 2 over 3. That's just roughly here, right? So we have 2 over 3. So later we're going to intersect here. Alright, okay. So now we're going to compare the table. So you have two tables, and then okay, it's actually much more easy to see. It's actually easier to see because the interval of the table is the interval of the table are the same. Okay, we have the negative infinity until 3 over 2, and you have 3 over 2 until infinity. Both tables are using the same interval. So back to the basic concept. Okay, let's just look at the interval of increase or decrease first. So look at the table first. Okay, for this interval, it says that okay, you're going to have a curve that is increase going up. Okay, the value of y is always increasing. Okay, and then you have to join the information that you got from the table of concave up and down. Okay, you will get it from here. So this is a plus sign, means that you have a curve of concave up. Okay, so okay, we're going to use your common sense. Okay, so we're talking about the interval from negative infinity is here, until the positive of 3 over 2 here. Okay, so you have these two region. Okay, you just observe this one as a borderline. So you're going to draw a curve that is concave up and is increasing. Okay, and you need to have your curve pass through those points, those intersect. Okay, those intersect point, and those curve that this curve that you draw should not pass through the dotted line. Okay, so use your common sense. If you want to have a curve, it is impossible to draw down here. If you draw down here a curve of concave up, what happens is if the curve is going up, so you're gonna cross the dotted line in here. Okay, we could not have something like that. Okay, so when we say you have a dotted line, you cannot draw a curve that pass through the dotted line. This is wrong. The asymptote means that your curve cannot pass through it, cannot pass through it, cannot cut through it. Okay, so now what you have to do is you have to use your logical common sense. You should have the curve and concave up, and it must pass through those intersect. So means that you're going to have here. So you have something like that. Okay, you're going to pass through the -2, and then you will have pass through the 203, and like that. Okay, so means that you have a curve that is the y value is always increasing by the when you go here. Okay, so the y value is always increasing. Okay, and how about the curve of concave? Now this is actually up, right? This is actually up. This is the curve of concave up. The curve of concave up. Then let's look at another interval. The interval that we have here, okay, we don't need this anymore. Okay, same thing happens. So, okay, we're going to look at this. Okay, this is also increasing, but you look at this table, you will have a concave now. So you have to join the knowledge of these two tables. Okay, so these two tables actually tell you what? Okay, it tell you that okay, you need to have something that is going up. Okay, the value of y is always increasing, but you have a concave down. Okay, so you're going to use your common sense. Use your common sense. So you have a dotted line here, dotted line here. Okay, so yeah, 3/2 is here, 3/2 is here. Okay, so if you want to draw the concave down, okay, if you want to draw the concave down curve, so what happened is we cannot have a curve that pass through the dotted line. So you're going to draw here either this region or this region. But if you draw it up here, if you draw the curve that is going up like that, then confirm you will have a curve that is passed through the asymptote. So this is not correct. Okay. So in order to have a correct, it must be down here. It must be down here the curve. Okay. So let us draw it. Okay. It must be from here to here. So as you can see that, okay, when I moving the x value towards the right hand side, okay, the y value is actually increasing. Your y value is actually increasing. Then when you go to reach your x value from the left to the right, okay, and you have the curve of concave now. You have a curve of concave now, right? Okay, so that is the way to draw the graph for example 1.